A very good afternoon, all the panelists and attendees. Uh, we know the biggest challenge every food processing industry faces today is the lack of advancement and innovation in its manufacturing practices. To bridge this upgradation gap, we at Neologic Engineers decided to present an emerging food tech webinar series where we will talk about cost-effective food processing automation, applications of top-notch machineries and technologies, and current trends and future directions in the food processing sector, and a lot of many things. We have been conducting such webinars since last 3 years, and in this 16th webinar of this series today, we will be talking about latest trends and technologies in fruits and vegetable processing. Let me introduce today's speaker, Mr. Sri Krishna Ozarkar. Born in middle-class family in Nashik, he completed his entire education in Pune by completing mechanical engineering from Pune University in 1987. After spending a few years in SKF, he joined Alfa Laval and worked in project planning and execution in the dairy and beverage sector of the manufacturing department. He started his entrepreneurial journey by starting his own firm in 1996 and eventually merged his business areas with Neologic Engineers. Professionally a hardcore technocrat, engineer, and a valuer, his interests are reading books and listening to Indian classical music. So, ladies and gentlemen, let me present our speaker today, Mr. Sri Krishna Uzarkar. Over to you, sir.
Yes, thank you, Nikhil, for the wonderful introduction. Good afternoon, everyone. And as the topic suggests, what we are going to see today is the new or the latest trends and the technologies in processing of fruits and vegetables in the processing industry. So let's try to understand what is the agenda of today's webinar, what topics or what pointers we are going to cover. So first, we'll try to understand why fruits and vegetable processing is necessary. Second, we'll be also taking a look at what were the earlier ways of processing. Third, what is the current scenario in the industry? And the next fourth is upcoming trends or what is happening, what are the latest technologies in processing of fruits and vegetables. And then fifth, a very important aspect, how we can add profitability to your processing line. So all this we are going to cover in this particular session. So let's begin. So first, try to understand why fruits and vegetables processing is required. See, we are as India are the second, and we are called as the fruit basket of the world. But although we are second largest producer of the fruits and vegetables in the world, we actually rank in last few in terms of processing capacity. Many times we have seen photographs in the news media that a lot of tomatoes are being thrown away on the streets by the farmers because the cost of the transport to APMC or to the market is far more than the rate the farmers get. This all can go into the processing section. These years, also government is giving a lot of subsidies. These are in terms of giving subsidies to processing, and they can be up to 35%, even 40%. And in some rare cases, it is also up to 50%. And we also have PLI linked scheme, which a lot of companies are getting benefited out of that. As I mentioned, we only contribute to 1% of the processed food in the world due to very high wastage. India ranks in one of the very high wastage in terms of fruits or vegetables. The term sunrise sector has basically arrived because of the fruits and vegetable processing industry, because that has been growing in last 2 decades with such a space that it is called as a sunrise sector because it is boosting the economy. And apart from that, we are also major exporter for the entire world. Now let's try to understand why fruits and vegetable processing. Every fruit has a season. Take a typical case of mango. We are in the summer season now, and this is when the mango will be arriving. So maybe the month of May, June, and July, in very some rare cases in South India, we can have up to August, the mango season. But throughout the year, we want the mango drink. So whether it is a slice, whether it is a fruity, whether it is any other mango-based drink, we are still looking for that. So how this is possible? So this is possible by processing and storing it into aseptic bulk packing, which has got a shelf life of 24 months. As you can see, if I got a shelf life of 24 months, I can actually export my mango pulp, my guava pulp, or my tomato paste to Australia, to North America, to Africa, or to different continents across the globe, because I have got a shelf life of 24 months for that particular aspect. So this second aspect, increased shelf life, is also very important. Third, the global reach. As it is aseptic pack, it can be safely shipped in the containers, in the drums, to various countries, various continents, and that is why it has got a global reach. And availability throughout the year. This is what we were talking about when we discussed about the beverage. So if I want a mango-based beverage and the season is, say, in the month of, say, September or October, where we feel very October heat is there, and I want to mango drink, then the mango pulp is still aseptic pack, which I can convert into a mango beverage. So this is why the processing of the fruits and vegetables is also important. And if you can see in the center, there is one of the most important aspect, that is going to give boost to your agri economy, which is very important aspect. So like I mentioned, people are throwing tomatoes on the road, so that can be all go to processing. In fact, processing people can take them immediately. So let's try to understand what were the earlier ways of processing of fruits, vegetables, or typically whatever we used to get in earlier times. So the most commonly or the earlier ways of food preservation was either through a sugar syrup or a salt syrup. So the life of that particular fruit chunks or lemon pieces, like we know that if we prepare a pickle, it is having a lot of salt and a lot of juice of lemon. So these were the earlier ways. And in some cases also sulfiting. This has been going on since 17th century. And the canning, the typical canning, which was very popular maybe 20 years back, actually started in 18th century and got evolved over the years. These days, a lot of countries have banned the tin products or the canned products, but we'll not go into that particular details. Canning is a general term, as you can see, which is applied to a process of packaging of food in a container and subjecting it to a thermal process. So it can be hot filled, retorted, or it can be hot filled and cooled, depending on what kind of shelf life we are expecting. The optimal thermal process in this way is going to destroy the pathogenic bacteria and kill or control the spoilage of organisms present and have the minimal impact on nutritional as well as the physical qualities of the food. This is a very important aspect. So let's try to understand the evolvement of the canning industry. So on the right hand side, you can see a photograph having a lot of cans, maybe with mango pulp or with some other pulp has been stored. And these are stored in their godown or something. These were typically retorted in a basket type retort. And the revolution or the evolution thereafter was to have a typical linear tunnel. So the cans will be hot filled. They will be passed through a linear tunnel, which can have a hot holding station and which can have the different cooling sections. So this was a typical process which was followed or even followed sometimes today also for canning people. Later, as I mentioned, in the process of mechanization, these linear tunnels were included in the process. Let's try to understand the limitations in canning process. And also let's note that a lot of countries or customers have banned product from the tins because of the limitation of the shelf life, as well as because of the lead content in the tin. So the old way of canning involved a lot of labor, as the process was completely manual. The process was not so hygienic. It spilled a lot of water outside when the beans were taken out from hot or cold bath. Typically, they didn't have a temperature control because all the process was manual. When you have to lift from the basket or put it in the into the bath, all the process was manual, and in between you can actually lose the temperature control. The entire process was accident prone, was leading to a lot of injuries and stoppage of work during the process. And even after the linear tunnels arrived, the energy consumption was high. It occupied also a lot of space on the processing floor. So this particular aspect was also wanted a revolvement, and it has taken place over the years. Let's understand what is the current scenario in this particular industry, fruits and vegetable processing industry. We have something called as a bulk aseptic pan, which is nowadays universally used method for storing of pulps, purees, or paste. And this becomes all the raw material for your beverages. This becomes the raw material for your ketchups. So everybody is taking out from the bulk aseptic pack and going ahead. So this was in the 70s when the bulk aseptic packaging was introduced with a sprouted pouch. You can see the picture of say a typical 220 kg bag, aseptic bag, and it is stored in the drum so that the bag doesn't get exposed to a typical what you can say pointed atoms, so that the bag doesn't get punctured. In India, this technology also got evolved in some, I believe from 1995, 2000 or something like that. Some of the most distinguished advantages of this system are it has got shelf stable, no refrigeration required, so it can be stored in the ambient temperature. Extended freshness and longer shelf life, as I mentioned earlier, up to 24 months. No preservatives are required. This is entirely natural pulp, natural puree, or natural paste. Optimal flavor, texture, and nutrient retention. Of course, these become the part of the process. Eliminates cost, logistics, and energy used in the cold chain. So if I'm storing everything at ambient temperature, I'm eliminating all this cost of logistics, storage, and everything. Let's have a look at the basics of bulk aseptic packaging. As I mentioned, pulp, puree, or paste, that is concentrate, are sterilized in aseptic sterilizer. There are bags which can be of bulk aseptic bag can be of 220 kg, 1000 kg. These bags are pre-sterilized with gamma rays, and then they are used to fill the product in a sterile or inert atmosphere. Based on aseptic sterilizer capacity, aseptic filler can be single head or double head. When we are using single head, the product can undergo recirculation, or it can have a aseptic tank, which is going to be in between. These bags or the fillers can be used also for smaller bags. So we discussed about 220 kg bag, we discussed about 1000 kg bag, but there are bags which are of 3 kg, which normally we use as a sample bag. Then we also have bags for 5 kg, 10 kg, and 20 kg. 20 kg option is also getting very popular these days. These are some of the typical photos of aseptic sterilizer. As I mentioned earlier, when we say aseptic sterilizer, the entire process is carried out in an aseptic environment. There is no exposure of product anywhere to the normal ambient condition. On the top left-hand side, we have a typical, 3 ton per hour sterilizer, typically used for tomato paste. On the right-hand side, the other view of that. What you see, a rectangular, typical homogenizer-like look is basically piston pump. This piston pump is going to overcome my all pressure drop happening in different models. On the left-hand bottom side, you can see different structure for the modules. On the bottommost portion, we have the heating modules. In between center, we have the holding modules. Then we have cooling by cooling tower water, and then we have cooling by, say, chilled water. So different combinations, different applications can be developed through this. Aseptic fillers, this is a typical photo of single aseptic filler. As I mentioned, when we are changing the sprout or we are changing the bag, the product will undergo a recirculation for a few minutes, or it can be stored in aseptic tank for a few minutes if we want to avoid the recirculation, or we can go for double head. So this is the typical photo of old double head design. And on the bottom side, you have a typical photo of new aseptic double head filler design, in which we can actually see there are two heads. One head is for filling of 1000 kg and one head is for filling of 220 kg. We can have combination of both. So we can have both 220 kg, both 1000 kg. This of course will depend on our capacity, how much you are going to market, what is going to be the speed and all this. These are some other varieties of aseptic fillers. On the left hand side, the picture which you see is a typical double-head aseptic filler with revolving heads. Revolving heads means revolving bottoms. When I put 4 drums on a pallet, the filling machine will fill the first bag. Then the bottom pallet will rotate itself. It will go for the next bag. The next bag will be fitted by the operator. The automatic filling will start, and then this will happen for third and fourth. So after my 4 drums are filled, the entire pallet will be shifted by a roller conveyor to some next station for the storage. On the right hand side, you see a typical monoblock, what we call as a monoblock. So monoblock is a typical structure where I also have aseptic filler along with aseptic sterilizer. So these are not into 2 different cabins. The left hand side, you see a typical aseptic filler is in a different cabin than the aseptic sterilizer. But on the right hand side, you see the model which is having the aseptic filling heads attached with the sterilizer. Let's also try to understand what kind of fruits and what kind of ways we can actually process the fruits. So when we say tropical fruits, the typical tropical fruits are mango, guava, papaya, and tomato or sapota. So these are the typical fruits which we call as a tropical fruits. And this can be processed into purees, nectar, cloudy juice, diced fruits, peel fruits, and other things. So here you can see the picture of what I've been talking about. The second aspect is the citrus fruits. The citrus fruits typically engage lemon, orange, kiwi, or sweet lime. We all know these are the citrus fruits. And then from this, we can have the clear juice concentrate, which can be frozen or it can be also in the aseptic. People will normally prefer for the frozen because at that particular bricks level, it is already a sterile product. And the second aspect of this particular production line is the essential oils. So the essential oils which comes from the citrus fruit are very good and very popular for medicinal and cosmetics use. Then we also have candies. These candies can be prepared by the natural fruits by dehydration process, and then there can be also the sugar coated candies. We also have lines for jams and marmalades, and the typical specialty of us that the whole fruit jam. So suppose imagine that I have got a strawberry jam filled in a jar, and I also have a typical full strawberries embedded in that particular jam. Then it gives a very good mouthfeel. That is why this particular item is also getting popularity these days. In vegetable processing, because tomato is a part of the vegetable, and tomato can be processed into typically a juice, paste, ketchup, peeled tomatoes, diced tomatoes, and a lot of other things. We also have something as called as a potato. Potato, it can be converted into chips. It can be converted into French fries. It can be converted into potato flakes. So depending on the application, the configuration of the line will be entirely different. Third, the important aspect which we are going to discuss now is the leafy vegetable. So there is something called as a portion products. So these typically you can see the portions of spinach converted into a cube, converted into a cylinder. And the beauty of this particular machine or atom is it doesn't cut the leaves, it just compacts them. So the moment I put these cubes or cylinder into water, the whole leaves are back to life again. So that way I can prepare this vegetable or sabji at home whenever I want. So we are not bound by that it is to be processed right now. On the right hand side, you can see a typical machine of portion products being underrun or under trial. We are also into fresh cut salads. We will not go into details of this. So let's try to see the next aspects. Okay, so let's try to understand the upcoming trends or the changing trends. So we are not just going to cover only the upcoming trends. We are also going to see the changing trends and also what are the different technologies which are getting developed in the coming years. So here you see, we saw that aseptic technology, but over a period of time, there is something called as a bag in box. That technology has been developed. And on the left hand side, you can see a single filler head for the bag in box. And on the right hand side, you can see a double head aseptic filler for the bag in box. And typically these bags can be 3 kg, 5 kg, 10 kg, and 20 kg. The beauty of this particular product is that the second line, which you see on the right hand side, has got the bags attached to each other like we have shampoo sachets, and the machine itself takes up the bag, it takes out the sprout cap, it fills in the aseptic condition, it puts the sprout cap again in the aseptic condition, then it cuts it from the film, and then the entire bag is going out. So this is an entire automatic operation. And this particular 20 kg or 10 kg bags are very popular. So these are some of the changing trends in aseptic. So a lot of people go for bag in box filler, or even there is also technology that we can have additional fixture developed for your existing bulk aseptic filler to have small bags filling. Portion product, which we covered slightly earlier, but this is also another machine or another line which is getting developed due to different requirements or due to the changing environment. So here we all understand that the nutrition compact them. So what we do, we just wash the vegetable, we cut the root portion or the stem portion, and the entire leafy portion we are going to compact in a die and punch mold, and that can be converted as a cube, that can be converted as a cylinder, and then this goes for the frozen line. The beauty is that once I take out one cube, it can be still converted back by putting it into water into the leafy portion, and then I can prepare the entire vegetable. Also, this is possible for different combinations. So I can have spinach and cheese, I can have spinach and different veg, and all these combinations are possible. So this is also another changing trend in the processing of fruits and vegetables. Another important we have plants in China where the typical capacity of a line, in fact, we have a plant in northern Mongolia where the capacity of the plant is 120 tons per hour. So here in India, we talk about 20 tons per hour, 15 tons per hour. But in China, we have plants of 120 tons per hour. But typically, our machines or our lines should be suitable to Indian conditions. And hence, the smaller pre-assembled model processing units are also getting developed. So looking at, as I mentioned, looking at our Indian agri sector, these processing units are getting developed, and these are typically located where the farms are there. Neologic, along with the Italian partner Fenco, we are developing these smaller pre-assembled processing units so that the smaller need or the smaller farmhouse output can be catered with this particular typical type of units. Typical advantages of these kind of units, as I said, requires very less space, easy to install, operate, and maintain, can cater smaller capacities, typically between 1 to 3 TPH, depending on the fruit, of course, and can be extended into additional modules in future. So suppose I have taken 1 TPH module or typical unit, I can expand it in the future. If I am aware that I'm going to expand, we can add the modules at a later stage. Also, these are budget friendly and of course hygienic design with effective CIP, which is more important for any processing industry. This is a typical photo of a tomato puree sterilizer, typical capacity of 1 ton per hour. And as you can see, entire thing is on the module. So it will come in a box. You just need to connect water, product, electricity, steam, air, and all the utilities, and the things will be installed very fast. In the age of internet, this is a very important aspect. This is being followed by every industry now. So IoT-based plant operations and monitoring. We all know this is for faster implementation. It has got lower implementation costs. It has got a traceability. I can have a real-time management for critical systems, critical information on mobile platform, can have automated work management system, and products module flexibility is also possible. So with this, we can have the increased plant utilization and efficiency because I can monitor even on my mobile. Changeover downtime is reduced because everything can be controlled by sitting where you are. So I can actually reduce any problem or any downtime which has happened, say for a plant in Jammu, by sitting in our Pune office. Transparency and flexibility in the production, energy and resource efficiency, vertical integration is possible, and raw material consumption mass balance can be traced throughout this. So these are typical applications, and IoT based, I don't have to explain. This is also the changing trend or the latest trend for this. Let's try to understand the emerging technologies and the future trends, what is going to happen in the future. So before we actually tell you what are the emerging technologies, let's also take a note that these are being under trial, these are going under testing, and there'll be few years down the line, once these are proven, these can be actually implemented. So ozone treatment, it is going on right now for different products. Of course, the product configuration will determine what can be done under ozone treatment. Ultraviolet membrane processing. Membrane processing is actually getting very popularity these days, and there are a lot of applications where membrane processing can help different products. Enzymatic mechanization, this is also possible. Freeze concentration, freeze drying, this is also happening. This is also getting developed. Then we have something called as a high pressure processing. Of course, the cost and other implications also need to be considered while we are going for this application. There is another area where we call it as a pulse electric field processing, and this is also possible for processing of different fruits and vegetables. Microwave thermal assisted sterilization, what we call as MTAS, this is also getting developed. So we are just getting touch base on the different technologies which are upcoming or which can change the future. Very important aspect, we are going to touch this particular aspect in detail. So this is for increased product recovery, increased profitability. So the lines can range between 1,000 kg to 20,000 kg in India. And as I mentioned, it can be up to 60 tons per hour. And even a small change of 0.5% in the yield is going to actually change your entire revenue model for the day, for the year, for the month, or for the season. So this is where the company like Neologic or the advisors in this particular field are going to help you. So to increase your yield, to increase the percentage change in the recovery. And if you use the latest technologies, latest tricks, and effective processes, this can be possible without compromising the product quality, texture, aroma, and flavor. Of course, the picking systems have been used quite from some time, and these are also recovering the product lost in the pipelines at the end of the cycle. Important aspect, converting single fruit plant to multi-fruit plant. So typically in South India, we had a lot of plants typically for mango processing. And over the years, people have developed these into a multi-fruit processing plant. So for a mango plant, if I require a certain set of machines, maybe for processing of guava, processing of strawberry, processing of tomato, I will require some additional machinery into that. And with few additions, so if I add few machines, if I increase my capital expenditure by certain percentage, how much percentage, that will of course come to know in the coming slides. Actually, I can convert a typical mango line into multi-fruit line, which can process mango, guava, papaya, tomato, sapota, and many other fruits, including strawberry. So as we know, the seasons of each fruit are different. We can actually utilize that mango-based plant for different fruits for different seasons. So I can have typically mango season for 3 months. I can have tomato season for 2 months, twice in a year. I can have a guava season for 45 days to 60 days. So this way I can actually increase my entire product, entire plant utilization for 200 days, 250 days, or even 300 days. So processing plant can be operational because of the multi-fruit processing line, at least for 8 to 9 months. That is what we said, about 200 days. It will give you faster return on the investment because I'm processing a lot of different products. And as I said, for a single fruit processing, a typical 80% of my investment, I don't have to invest more. I can just add 15-20%, and this can be converted into a multi-fruit processing line. And these are lines are custom built based on the availability, product configuration, overlapping of the seasons, and of course the place where the plant is being put. So all this will happen, or that can be custom built. This is a typical flow chart of a multi-fruit processing line. What you see right now on the screen is a single fruit processing flow, typically for mango. So when I say the fruits receiving, those are received and taken into a flume. Then I go for primary fruit washer. This is a typical example of primary fruit washer. We can also have secondary fruit washer. So here you can see totapuri mango being washed. Then I go for secondary fruit washer, which we are already aware. We go for sorting and cutting conveyor. So for tomato, I will have roller conveyor sorting, and I will have west conveyor over here. Typically for mango, I have a 3-tier conveyor where I am going to cut the tip as well as one cut. Then I go for slat elevator where my fruits are being carried, and on the platform I have the destoner. So the destoner, typically everybody is aware. Then I will go for pulper finisher. After pulper finisher, I will have buffer tank. Post buffer tank, I have got the preheater to heat my pulp from ambient temperature to 55, 57 degrees, which is going to be ideal temperature for separation. And then I can use decanter or separator for separation of my black specks, brown specks, and other aspects. Then again, I go for standardization tank where I can maintain the acidity of my product. I will go for aseptic sterilizer. This is the typical aseptic sterilizer for tomato puree. Aseptic filler, single head, double head, depending on the configuration and capacity. And then we have the ambient storage. Now, in the green is the multi-fruit line. So by just adding few machines, I am going to have the entire processing line typically used apart from mango. So if I have to use guava or I have to use cold break tomato, I will use a typical hammer chopper like this. Then I have got a hot break, which is typically used for hot break tomato paste. So here you see on the right hand hot break tomato paste along with the evaporator. This is a photograph from Punjab. Then we have a turbo refiner, and this turbo refiner is going to take out your waste for the peel and seeds. And I need to mention that Neologic is the only manufacturer of turbo refiner in India as of now. And then we have the evaporator. The evaporator can be double effect, triple effect. Here you can see typical triple effect evaporator along with hot break for a plant recently installed in Bihar. The capacity of this plant is 20 tons per hour. So by adding few machines, we are just going to have the entire single food processing line converted into multi-food processing line. Lines, some of the facts of those lines, these lines can be typically from 3 tons per hour to 60 tons per hour. Not that we cannot give you 1 ton per hour line, but when what we call as a threshold capacity, where your investment and return on investment can be a good one, is typically what we call as a 3 ton per hour. The final products can be stored in aseptic bags, 3 kg, 5 kg, 20 kg, 220 kg, and 1000 kg. And of course, with a shelf life of 2 years. And the area required for this multi-fruit processing plant, typically for 5 ton per hour or 6 ton per hour, it can be around 4 acres. See, here we require around 25-30,000 square feet for the processing hall, but we require a larger space for ripening because mango comes in unripened condition, and I require say 5 days ripening cycle. So I will require 5-day chambers to store the mangoes to get it ripened. Then of course I will require finished goods storage, laboratory, and other aspects. So this is some of the facts of the multi-fruit processing line. Here we also understood how by converting a single fruit processing line to multi-fruit processing line, we can achieve more profitability. So just recap about what we have gone through. First, we understood what is the need of the processing of fruits and vegetables, and typically in India. Second, what were the earlier ways of processing of the fruits and vegetables? What is the current scenario, how the fruits and vegetables are processed? What are the latest trends, changing trends, and what are the different technologies available in processing of fruits and vegetables? And then how we can actually add profitability to processing line. This is what we have gone through in this typical recap. All the attendees can take a snapshot of this. And if you have any query, if you want to get in touch with for more details about any of the processing aspect which we have discussed, you can take a snapshot and then we can be in touch with each other. Okay.
I also sent one appointment link in the chat box, wherein people can book a 60-minute slot with one of our experts, that too with the free of charges. And they can talk to our expert for 60 minutes. They can resolve their queries as well.
Very nice.
Yeah, as a panelist, I'm looking at all the questions that has been received here, and I think there is a very enthusiastic response from the audience. And so I just like to take you through the some of the questions which can be answered here in this session, because some questions are actually very specific to their own plant or requirement, which will answer them directly one to one. One of the questions that's coming out is that is aseptic processing the only answer to to processing and packing of new technologies can, used.
There is a question from Takir site. Energy cost and per kg of the product. Of course, this will depend on the kind of processing capacity. The packaging cost, if I am typically processing, say, 220 kg will be different. If I am processing 3 kg, 5 kg will be different. So we can take this case to case. Please do write to us and we'll definitely try to help you on this. There is a question from Navneet Kaur. What is the equipment suggested for spinach pressing and rolling? So we have something called as a machine for portion products. Of course, our people will get in touch with you. We'll share the catalog for the same, and this is a unique machine. Very few people in the entire globe are actually manufacturing this machine. So we can share details for this with you.
Yeah, there is a very related question to the same thing from Nitin, that portion product Easy Cube, when we compress the leafy spinach, will it not lose its properties? And how do we ensure that the properties remain?
Very nice question. Thank you, Nitin. So when I press the leafy vegetables, there is some kind of juice which is coming out from the leafy vegetables. So in the machine, we have a system where we collect this juice and then we inject this juice back into the pressed cube or pressed cylinder. Back into the cube or back into the cylinder. I am not losing the properties, nutritional properties. I hope this answers
Yeah.
your question, Nitin.
Yeah. Miss, I want to add here that we are not going to mash the product. We are just
Correct.
going
We
to
are just going to
compress,
compact the product. Correct.
compact it. Yeah.
Correct.
There is one more question from Mr. Anil Pa. Is there any other technology present in the market for processing food, or is it only the way to process food through aseptic method?
Yeah, I think this question we answered earlier. As I said, there is a method for canning, there is a method for frozen, there is a method by sulfiting or adding some preservatives. So what we have covered in this webinar is the most attractive, most profitable, where you can have a shelf life, where you can have international standards meet. So that is the process which we have described in this particular webinar. So there is a question from Pooja Sampat Kumar. Will the portion leaves retain some nutrition as the fresh leaves? Yes, because they are not like Mr. Mahajan was mentioning, they are not mashed, they are just compacted. What is the approximate, this is a question from Sachin Adsare. What is the approximate initial capital requirement, 3 to 5 tons for multi-fruit? Definitely, Sachin sir, let's understand where are you going to put the plant, what are the different fruits or vegetables you want to process, and based on that we can give you a budgetary figure, what kind of budget or capital will be required.
So one question we have received on LinkedIn from
Yeah.
Mr. Amit Saha. Any specific technology for medicinal herbs processing?
So basically, not specific technology, but at Neologic, we are the solution provider. We take the complete care of your process. So this will be developed based on your requirement, based on your recipe, and based on what kind of product you are going to process. So this can be discussed.
One question from Mr. Takir, comparison of canning with aseptic tech.
So the comparison can be in different terms, in terms of technology, in terms of thermal treatment, because in canning we are not undergoing sterilization. So the entire comparison can be on two different fronts, the technological aspect, the investment aspect, and the third aspect is also about the shelf life or the customer we are going to target. So there can be different comparisons, and definitely we can answer him in detail on email about this.
One more question from Mr. Nitin. He's asking about is there any installation done by Neologic engineers for tomato processing plant, and what are the challenges you faced?
Yes, a good question, Mr. Nitin. So to tell you, the first plant of India for tomato processing has been done through our people. At present, we have more than 10 to 12 plants for tomato. Recently, we have completed installation and commissioning of a tomato paste plant, which is also having a tomato ketchup plant, and that is for the most famous brand, Kisan, that is Hindustan Unilever, and that has been carried out recently, few months back, and the production is going on.
I think we are done with the questions, sir.
So I think you can take up
Yeah.
webinars. Yeah.
So these are some of our upcoming webinars. Soon we will be sharing the notifications of these webinars, and you can also watch our recordings of the past webinars on our YouTube channel. I'm putting the link in chat box. You can visit the link and you can view all the past webinars. Almost 15 webinars are there. Yeah. Next slide, please. Yeah. So I thank you all the panelists and all the attendees for joining in this webinar. Thank you very much, Ozarkar sir, for the insightful session. And also thank you all the attendees for joining in. We will meet in the next webinar. Soon you will get the recording of this session on your email address, as well as the registration link for the upcoming webinar, which will be on high-speed dairy separators. Thank you all for the joining. Bye-bye.
Thank you.